if we are friends on LinkedIn or connections or whatever we're calling it now, this is what I've been squabbling about. MAC randomization. I was really excited that Jim not only put the blog post out, but was willing to take time out, come in and record this podcast, because from his perspective and from mine, this is a big deal. So whether you're aware of it or not, whether you're worried about it or not, Jim really lays this out. And there's so much information in here, and Jim has so much technical knowledge and depth in Wi-Fi that it's worth listening to. So we're not doing this to really have you jump up and down on a panic button, but there are environments that can be affected by this very negatively. So it's worth a listen. It's worth getting the information out there. All of the blog posts are linked in the description, including his own personal blog. So as always, sit back, relax, and enjoy. Jim, it's great to have you back. Thanks for coming.
Oh, thanks for having me.
So this was kind of interesting because when I saw your blog post, and I knew you were working on this for a while because we kind of talked internally, I started to share it out and have conversations with some, friends of mine that work in this industry. And I got feedback, and it was really interesting to me that a couple of them were like, wait, what? What is going on? What's happening? So MAC randomization is, first of all, I'm going to put the blog post in the description. And if you get a chance, you need to read it. It's excellent. It's very well written. You put a lot of awesome information in there. And the really cool thing was, as I was reading through it, I realized that as I'm reading one paragraph, I'm asking a question, and you answer that question in the next paragraph. So that's how really intuitive it is. But tell me, how did you get kind of roped into this? Where did this really stem from?
Like roped in from the beginning,
Yeah.
So it's actually kind of funny because I'm working on another post that it's going to go on my personal site, but it really explains that, and it really started last August. When I got a message from Mo Williams. A lot of your listeners might know her as Mo. She sent me a message, and she's like, "Hey, did you know they're doing this thing?" And I thought that she was talking about when devices would probe, and they've been doing that for a long time, actually. And the idea was, until I actually connect to your network, I'm going to try to, not let you know exactly who I am and how much I'm probing. And I was like, yeah, they've been doing that for years. And she went, no. She goes, this is when they connect and it's coming out. And I was just like, oh no, this is bad. And since August of 2020, it almost is like this rabbit hole that I keep falling down, and it just goes more and more and more. And I've done so many presentations and talks and people reaching out to me. It's sort of really taken on a life of its own now. And now here we sit.
Yeah. And I really wanted to get this information out there because when I first read it, my eyes went like saucers. So I was like, oh no. So this is a big deal. And I think that if there's not alarm bells going off in people's heads, then there needs to be, to a certain extent, because it's a big deal. So when we talk about MAC randomization, first of all, I think we have to kind of understand why there's this drive and push and need for it from vendors like Apple and Google and Microsoft, right? What is their end goal here? What are they really trying to provide the end user by doing that while providing us the headaches to deal with?
So, and I kind of go into this because the blog post is really a series, and I did 2 of them in September, and then the latest one that just came out this week was last week was about sort of that follow-up. It's been there for 5 months. What have we learned in that time? And it really and I'm trying to figure out how's the best way to explain this. One of the things I talk about is the fact that MAC randomization or random MACs isn't necessarily what it's called or what it's doing. It's what we see. We see a random MAC, but according to the IEEE standard, it's actually known as a locally administered MAC. But the software developers, like the people who write the iOS codes, Android, the Google people and Microsoft, they all call it a private MAC address. And so it's the idea is to try to protect users' privacy when they're going out and about in the world, because what ends up happening is as network operators see the device more and more and more, and they see it more often, they can start building a picture and building a story around what it is that person's doing and where they are. There's a story I don't tell very often about a time when at my previous employment, where I was able to track down the approximate location of a user on a large public network, just simply by knowing that his flight landed at this time from this city on this airline and the last time that they heard from the person. So using those 4 pieces of information, I was able to actually tell the police, hey, this person's within about 75 feet of this specific location in our facility, which has millions of square feet of public space. And so by building that picture around nothing more than those 4 pieces of information and looking at MAC addresses, I'm able to track people. I was able to figure out, as I know when they come, I knew, and I was able to learn a lot. And people freak out, and they probably should, over losing that privacy. So the idea behind, hey, we're going to take this and we're going to keep changing it and present new information to the network every time it sees you, it protects your privacy. So that's where this all stems from is, as we connect more, as we do more, as our lives become more automated, we're giving up privacy. We're revealing more and more about ourselves. And the operating system developers are trying to sort of pull back on that and say, hey, you know what, we're going to do what we can to try to maintain a user's privacy. And so the end result is they kind of push it back onto us to say, okay, we've now done this for the users. Now you have to deal with it and figure out how, what do you do with what we've done?
The list of questions that I want to ask is about a mile long, but one thing that came to my mind when I looked at this was, you can randomize a MAC all you want, but the OUI has to say the same, right? No matter what pool it's pulling from, or is it mixing that up as well?
So I'm going to get super technical, so I apologize. What happens when and this goes back to the world's made up of ones and zeros. The MAC address is made up of 6 groups of ones and zeros called an octet, kind of like an IP address. Mm-hmm. The most significant octet, the first one, contains 2 characters. And they can be, and they're hexadecimals, so 0 through 9, A through F. But when you break that down and you look at the bits inside of that, most significant octet, the second least significant bit in the most significant octet, if it is a 1 and not a 0, then that signifies that the MAC address being used is what's known as a locally administered MAC address or a random MAC. So what ends up happening is we used to be able to look at the OUI, the first 3 sets, so the first 6 characters, and say, okay, that is an Apple device, that is a Samsung, that is an LG, that is even APs use it, and you can say that is a Ruckus AP that is advertising that. But when you take that 1 bit, the second least significant bit in the most significant octet, and you change it from a 0 to a 1, all the rules are gone, except for one, which is that second character in the MAC address can only be one of 4 characters, 2, 6, A, and E. And I cover that in part 1 of the blog. If all you have is the link to the third part, the links to parts 1 and 2 are down at the bottom, but I kind of go into exactly how that is broken down from a ones and zeros perspective of, we now know that a random MAC address, if you see a MAC address and it starts with a D2, because it's a 2, we know that it's a private MAC, random, locally administered, whatever you want to call it. But we basically know that, hey, that MAC address is no longer, we can't hang anything significant off of that MAC address anymore.
Right. So what mathematically, I like asking you this question because you're about 3,000 times smarter than I am. Mathematically, what are the chances you're going to end up with a duplicated MAC on the same segment?
I don't know the math behind it. What I do know is that the possibility exists. It does. I mean, the possibility exists. The probability is really, really low because from a Wi-Fi perspective, you'd have to not only be in the same area, you'd have to be also on the same SSID, or which then goes into the BSS and the BSSID and the ESSID but a lot of technical stuff. But anyway, you would have to be on that same platform at the same time with the same. I mean, there's a lot of things that have to line up. So while theoretically possible, the probability of it is really low. And so that's why they've made this decision to say, we can go ahead and do this. We can make this change because the probability is low enough that we're going to sort of roll the dice and hope that it works.
Yeah, and I guess I kind of asked that question because things like large public venues come to mind, right? Where you do have everybody attaching to a lot of the common things that you're talking about. So that's where duplicates for network engineers, myself, you, everybody else, duplicates scare you, right? You don't want duplicates. And having, dealing with dynamic IP space it can be enough of a headache as it is. But now you want to do it, dynamic addressing at layer 2. That's a little bit more scary because what you start to introduce at that level becomes a little more terrifying, right? Especially when nobody's had to troubleshoot that before, right? Have you ever had to troubleshoot duplicate MACs on a network ever?
I haven't, because before now, every device was using a burned in one. And I've heard a story actually about a pallet of computers that was built and shipped from the factory. And what they realized is after that happened, they realized they had a glitch, and the device that was supposed to put the next MAC address on the next device got stuck. And so they built an entire pallet of computers that all of them had, and this wasn't for Wi-Fi, this was for the Ethernet. So the Ethernet NIC on a pallet of desktop computers was exactly the same. But the thing to remember is a MAC address is only significant on the local network.
Yep.
As soon as you hit that gateway, that default gateway, the MAC headers are stripped off and replaced with the MAC header for the next hop. So they didn't realize that this had happened until one organization happened to buy like 8 or 10 of these computers, and they installed them, and they were for one group. And so they were all on the same local area network, the same LAN, whether it's a wireless local area network or a wired one, until they were on the same one, and they went, wait, it's all broken. And somebody went and did a show MAC address tables command on the switch and went, oh crap.
Yeah.
They're all identical. I mean, they went back to manufacturer, and manufacturer's like, oh crap, we did that. So it doesn't happen very often. So being able to troubleshoot it, I mean, it's just like troubleshooting a lot of other network problems. You get this crazy complaint, and then you have to, if you follow the same troubleshooting steps, you'll find it eventually. It's just a question of how fast can you figure it out.
Yeah. Yeah, and that's the hard thing. I mean, you try to teach people when you start to troubleshoot things, you have an OSI model for a reason, right? Start at the bottom, work your way up, and you skip things as you go and you get more experience and I get it. But one thing I was kind of curious about too is I'm not going to sit here and pretend like Apple doesn't have very intelligent people on staff, or Google or Microsoft or whoever. But when I first initially read your blog post, one of the initial thoughts I had was, it sounds like this decision was made in a vacuum to a certain extent, right? They just decided that they were going to do this because their intent is to provide their users with privacy, which between you, me, and the fence post, to me sounds kind of like a marketing gimmick in a way, because the amount of fingerprinting that's done on clients today, like you said, you can still track stuff down. And like the blog post goes into, you can still track this stuff to a certain extent anyways, right? So you take an intelligent person that understands how this stuff works, sure, you can sell it and market it that way, but it doesn't seem as plausible as they're making it sound like, right? I mean, I just don't get that feeling, but maybe I'm a skeptic. I don't know.
There's a lot of marketing involved. I mean, you can't deny it. If there wasn't any marketing, then they wouldn't have called it private. They would have been like, oh, we're going to turn on locally administered MAC addresses, because that's what the standard calls it. But marketing gets involved in everything. But, again, leaning back on my experience, of having run a large public network, there is some, there's some concern there. I was able to track people. I was able to do a lot of different things that, and part of it is because I was trying to at the time, but in a bigger picture, I quite honestly didn't care because it's a lot of work to do it. But it is possible to track that kind of thing. So there is some privacy concern and there's some privacy issue. But, as most people know, to use the latest and greatest technology to be able to make technology work for us, there's a cost, there's a trade-off. And that trade-off is really sort of revealing more and more and more about yourself. Because if anybody's ever worked on a Wi-Fi network, they know how chatty that is and how much data and how much information is collected and gleaned from not necessarily the traffic you're passing. We don't really care, whether you're using Google or MSN to do your web searches. But we care more about this other information and data that we collect about you. I mean, and it happens with cell carriers. I mean, cell carriers do that right now. I've seen reports from the New York Times where they've tracked people that were in an event and they go, oh yeah, we can see them spread. And it's a big thing like with the COVID tracing that, is a big ask and request right now from a lot of network providers is knowing, hey, this person that we have now identified as being tested positive for COVID, where were they a week ago? Who did they come into proximity with? How did that all work? That's a big request right now. So it's this question of, I can maintain my privacy, but not have this ability to track a device or a device associated to a person who is now, tested positive for COVID. You have sort of this, where do you make that balance? How do you do that? And, we're starting to get into ethical discussions, which I'm the last person you want to talk about ethics with, or at least have that conversation. So it really becomes a trade-off, and where do you draw that line? And I don't think it's a question that you and I can answer on it, even on a 2-hour podcast.
Yeah. Well, and it's that thing, right? Everybody gave up. Everybody. It doesn't matter who you are, what walk of life you're in. There are levels of privacy that were given up years ago, whether you realize it or not, they're gone, right? So you can randomize my Mac. I'm an iPhone guy. I've been an iPhone user for years. You can randomize my Mac anytime you want, but that doesn't mean that my metadata that's out there is going to be any different. Doesn't mean that the fingerprinting that my client is doing is going to be any different. I mean, there's still a trail of breadcrumbs, right? I'm not going to be off the grid while I'm on grid. That's never going to happen.
The breadcrumbs are there. What's going to change is who's able to gather that breadcrumb trail. And so from an Apple perspective, they already have so much on you anyway. Especially if you've gone full Apple and you got iPhone, iPad, watch, laptops, what have you. You've kind of gone, if you've gone full Apple, Apple knows a lot about you already. But I think it's a question of trying to control who has that access, because now, say a hotel operator, they have a chain of hotels, being able to say, okay, Matt, you stayed in this hotel chain in San Diego this week, and now we see you in Boston this week. Apple knows that. Your cell carrier knows that. But now, in the past, the hotels have been able to track that and been able to know that. And they can look at it just by simply knowing your MAC. Now, that bar to gain that information has been raised to where the hotel now has to say, okay, we need you to do another step so that we can still provide you that same level of service that you expect. And we're talking about things like, knowing when you show up on property. Because your phone automatically connects to the Wi-Fi and they know that you're an honors member. And so they go, we know that you're in room, 427. So, we're going to get that whole process spun up and running on our side because you showed up on property. So before they could do that with just a MAC address, but now it's raising that bar to above layer 2, like you referenced in the OSI model. We need to have something above that, say an application on your phone that runs, so you can use whatever MAC you want. And so that becomes then a thing, and that the network operators are now forced to, handle and deal with, because the cell carriers and people like Apple, they've already done that.
Yeah.
So it's that extra step that is being put onto network operators. And I like to point out to people that this wasn't anything that any of the or the network manufacturers, the Ruckuses, the competitors of ours, it's not something that we went to Apple and went, hey, we want to sell more gear. We want to sell more services. We want to sell more stuff. So how about you do this? This is something that we're sort of in, just like with end users, with, network operators and network vendors, we've all had to adjust and come up with ways to handle this, but it wasn't something that any of us requested.
Yeah. So it's funny, you mentioned Mo earlier. From the education stuff in terms of like podcasts and live streaming and things like that we're doing, we're going to start to do a lot more things starting in March, probably focused around best practices, right? So I had a discussion with Mo about it the other day, because we have so much great information out there that I think we just need to kind of help spread it out a little bit more. But one of the reasons why this concerns me is we've harped on for years and years and years and years to have best practices, to have standard configs, to have these things built in and baked into your network, because it really reduces some of the headache that you're going to run into, right? You can't just go out and configure 7 sites 7 different ways. It's going to cause problems. Plus, when you bring new people in, it makes it harder for them to get up to speed, troubleshoot it, things like that. We all know that, right?
Right.
But now we start to take things like this, and we have to take some of these best practices that have been baked in and solid for the better part of 20 years and flip them on their head. For example, how do we handle DHCP scopes, right? If I have a scope out there of 254 addresses in a Class C network, and now all of a sudden I start to randomize MACs for people that are all showing up at different times, and I don't have lease time set up correctly, I'm going to have a bad day. And not everybody has a handful of IPs that they can sit there and throw at it and change subnets and make their subnets larger or route them differently or whatever. That we look at this stuff from our standpoint and say it's fixable, it's doable, absolutely, but it's not a simple, quick thing. We can't sit there and say, oh, hold on, I'll be right back, and 5 minutes later you're up and running, right? It's a big deal. And,
it's funny you bring up DHCP scopes and stuff like that. It's not that this information hasn't already been there. I mean, I ran into a situation years ago where I ran out of DHCP leases on a pool that it was a /18. So that would have been 16,000 IP addresses, and I ran out of IP addresses with 16,000 IP addresses in the pool. So, and I didn't have random MACs to deal with, and so what I like to tell people is one, I said it back in September, and one of the reasons why I came out with the blog post now is to remind people that we're still not out of the woods. We still have work to do. There are solutions out there to solve this problem. Some of them involve additional services, servers, but some of them also involve taking a look at your network and making sure that you did things the right way and you didn't cut corners when you first initially configured it. So your best practices that you referred to from, say, 15 years ago. Well, I mean, think about how much has changed in 15 years. Think about how many different devices that you carry. I mean, I remember I took a trip 2 years ago, and going through airport security was a nightmare because I had 3 laptops, 4 tablets, a bunch of phones, and a bunch of other stuff. And I literally ran out of space on the belt where you put all your bins and everything to put just my electronics in. Yeah. I'm like the worst person to ever go through an airport, and you don't want to get stuck behind me. But things have changed. So the best practices that even, from 5 or 6 years ago are starting to change, but a lot of it is not so much of you need to check this checkbox on this section of the configuration. It's the best practices are now sort of starting to evolve to, let's sit down and have a conversation. And from whether you're an SE, whether you're a partner, whether you're a vendor, let's sit down with the network operators and get a better understanding of how they want their networks to work. What are the problems they're trying to solve? What are the pain points they have? And that's where best practices really need to start, because it's not a one size fits all. It's not a every seven, you can't set up 7 sites identical unless they do meet all the exact same criteria.
Yeah.
But you have to start, instead of starting with, hey, these are the check boxes that you do. This is the pool size. This is the lease time. This is how you build ACLs. We can't do that anymore. We have to sit down and say, let's identify your problems and pain points and then come up with a solution that meets that, as opposed to just saying, check all these boxes.
Yeah. If we ever travel together, we have to show up at the airport about 30 minutes apart, because by the time you get through security, then it's my turn. I used to pack my bag leaving certain parts of the world specifically so that I could get everything out in a certain order and then put it back in my bag in a certain order, because the same thing. 2 laptops, iPads. It's just a pain in the butt. So, it's really interesting looking at all of this stuff, because first of all, the industry is extremely lucky to have folks like yourself that take the care and feeding into this, because it's highly important, right? I mean, there's ways we can look at this stuff and maybe turn the other cheek and say, well, you guys go figure it out. But that's the big thing. And I used a /24 for a DHCP scope, just to kind of scale it in a certain way. And you're talking about a /18. You start to put this stuff at scale, you realize how monstrous it really is, right? It's huge. So, to steal a quote from my dad, when I'd sit there and bellyache about something silly that I had to deal with, you just say, oh, job security. And to a certain extent, it rings true, right? I mean, it really is. There's always going to be things that we have to handle and deal with that none of us planned for, right? Vendors do whatever they want when they manufacture hardware. We have to navigate around that. And that's kind of the continual battle of where we're at, not only the operation of the network, but how do you future-proof for what you don't know?
And I mean, it's a good question. I mean, how do you future-proof? Because there's not that silver bullet. It's this idea of needing to understand not only the 802.11 standards and processes and how that works, but also 802.3, because at the end of the day, there are still certain things within that will ring true no matter if it's technology that's coming out tomorrow or technology that came out 5 years ago. Yeah. There's still this thing of you still need a MAC address. You still need this, because that's just how switching and routing, the 802.3 and how 802.11, it still has to sort of rely on that, because if you get off of that standard and you say, you know what, we're just going to go off onto our own and do our own thing, then you run the risk of things not working. So there still needs to be this framework, and that's where understanding this stuff, even if it's scary, even if the answer to random max is, you have to sit down and set up a full-blown PKI, public key infrastructure in your organization and start using .1x and start using Radius and start using all these things. The solutions are there. You just can't sit back and skate on it anymore. Yep. Because 802, honestly, WPA2 Enterprise and WPA3 Enterprise are pretty close to the same. And WPA2 Enterprise came out in 2004.
Right.
And yet even the revamp one is just simply a matter of, additional, size of the encryption key.
Yeah. I'm going to put my tinfoil hat on. I have a theory. I really and truly believe that there is a certain push within the technology world to start to introduce things that begin to force networks and network operators into IPv6. And it's not a completely harebrained tinfoil hat theory. I think it's just that when we look at the amount of devices that are out there that require an IP address, RFC 1918 space, you can use it all day long. Regardless, you still have to route it somewhere, right? Things have to be routed, so you're natting through one public IP address through a carrier, whatever. It still exists, and the pools are still depleted. I mean, we've been having this conversation for how long now? But it solves a lot of problems. So PKI is one of them, right? And you look at that and you look at what that solves, but then you still have the underlying layer 3 infrastructure that has to live there. V6 is going to get there, I think, at a little bit faster clip as we start to see these things come in, because it eliminates all of those problems. It introduces a lot of other problems, but it starts to eliminate some of the gotchas that are out there, right? You're not going to deplete DHCP pools as fast if you're dealing with 128-bit addressing, right?
It solves the problems that happen at layer 3, but it still doesn't solve issues that happen at layer 2. I mean, we still, you referred to the OSI model. We still, I mean, 802.3, 802.11, that's kind of, that's sort of that base that was, I kind of say layer 1.5 type of thing. But at layer 2, where Wi-Fi lives, it's still this question of how do you securely connect devices to an access point? There is still, if you're using any type, and that encryption lives at layer 2.
Yep.
So, PSKs, pre-shared keys, dynamic pre-shared keys, all of this stuff, it still lives at layer 2. So you can have an IPv6 address all day long and it will take care of DHCP pool exhaustion. It will take care of, sort of that half of it, but you still have this thing of Wi-Fi lives at layer 2. You can have 4 different addresses in a frame, in a wireless frame. You can have the source, destination, transmitter, and receiver address, and those are all MAC addresses. Those are all still 4 MAC addresses. So IPv6 that lives one layer above that at layer 3 is still below your addresses that live on layer 2. And so, I mean, I had a question that came in just this morning about, well, what about domains? I don't care about domains because that lives above layer 2.
Right.
So IPv6 is, I mean, it's funny. I heard a story about a network problem that happened at a conference in Asia, and they couldn't figure out what was going on until they realized that there are websites now that are being built that only have IPv6 addresses, and they won't accept an IPv4 source address. So even when they NATed and they sent the traffic out to the internet, the remote site was like, oh no, you're an IPv4, I'm not accepting you. And so users were complaining. They thought it was a Wi-Fi problem, but it turns out it was because they weren't running IPv6 on their network. And so it's getting there, it's going there. It's going to be a lot slower to solve, because of NAT, because of stuff like that. And, a point I talked to, I tried running IPv6 in my house, except my local ISP dropped their V6 gateway for, 8 months last year? So I couldn't run IPv6 if I wanted to.
Right. Yeah.
And that's the ISP's problem. That's not my problem.
Yeah, and I kind of poked that on purpose because there's something. So look at the ICX family, right? Look at any router, any switch, whatever. It has a CAM table. There's only so much space you can get in that CAM table. Okay, now I'm going to take tables that allow for layer 2 MAC addresses, and I've got X amount of space for those. I've got X amount of space for the layer 3 addresses that I'm going to stick in it. Now I'm going to put V6 on top of it, which is exponentially larger. How big am I supposed to make this CAM table, right? I mean, if you architect the hardware incorrectly, now all of a sudden you have a conference, right? Everybody shows up. All their Macs are there on day 1 at 8 a.m. The next day at 8 a.m., well, Macs have to age out. So once everything flips at the same time, guess what? You just doubled the amount of MAC addresses sitting in that CAM table until all of the other ones age out. It's the problems are paramount that we're going to run into. And once we start to see them, that's where we're going to have to, we've got to educate people on what's going on and what to expect when these things start to come up, right?
And that's what we're trying to do. Especially me and the team that I'm on, and what we're doing, and that's hence the blog post, this podcast. I did some training videos a couple of weeks ago about this, for our internal SEs, so that we can, still, because this is coming and it's going to get worse. It's not going to get better. And I feel, and from what I've heard and seen, I mean, even people on my own team sent me a message, a month ago and was like, I don't understand what you're talking about with MAC randomization because my MAC hasn't changed in months. So what's the big deal? And I'm like, oh, no, it's coming. And so I had to make that explanation. And so that's what I'm trying to do is there are ways to fix this. DHCP addresses, reduce the lease time. Your CAM tables, again, reduce how long it keeps that before it flushes it. When you look at MAC addresses, this is something I was having a conversation with the Cloud Path folks about 2 weeks ago, is if you know that the MAC address that we've identified as the second character being a 2, 6, A, or E, if we know that that MAC address, is a locally administered MAC address, you can look at it and you go, oh, second character is an A. I haven't seen it in 2 days. I'm probably never going to see it again. So flush it. And that's even at a database level. I mean, when you start talking about CAM tables, that's an easy fix from a concept. Same thing with IP addresses. Oh, I haven't seen that MAC address, and it's a 26A or E, flush it.
Yep.
CAM tables, same thing. I mean, I'm not smart enough to go write the code that does all that, but in talking with the people who are, that's the feeling I've gotten is there is still work to be done, and we're having this conversation internally within the Ruckus teams, within the Wi-Fi teams, the cloud paths, the Ruckus analytics, the smart zone, the ICX. We're having these conversations, but that's great and it needs to happen. But at the same time, the reason why I'm doing this is to make sure that our customers understand, this isn't just something that we're going to fix with a magic bullet. It's going to take work with them. And so I'm trying to sort of get that word out of saying, Apple gave us a warning in August of 2020 when they came out with this 24-hour feature, and then they dropped it. But it really was a warning of it's coming, it's going to come back. And I explained that in the blog, my whole reasoning. So I won't go into it here, but it's coming back. And we have, I think, until September when iOS 15 rolls out. So we have the time if we put the effort in today. If we wait until August when iOS 15 beta 3 comes out and they go, guess what, jokers, here's your random MAC every 24 hours and we're not taking it out this time. If we wait until September, we're going to be in a world of hurt.
Yep.
So we're, as Ruckus, as CommScope, we're trying to get that message out of saying, you know what, we're going to be proactive. We're going to make sure that we at least have some answer for you come September, and hopefully some solutions that are viable that will work for you.
Yeah. You know what would probably make me the absolute happiest is if somebody, friend, colleague, friend of a friend, whatever, came back at some point and said to you or said to myself, hey, I had to go to a job interview and sat down and talked to them. And this very discussion landed me that job because they weren't prepared for it. Right? I mean, you look at how we architect networks and all the different functions that they have in different areas. Here, you go to an office, right? Everybody plugs their laptop in, plugs a cable in. Do I care about it at that point? Maybe not as much, right? Take large venues where I'm going to have tons of mobile devices in there that are going to be flipping Macs like that. Hey, what about Mac age, right? What about timeouts? Does it really, I mean, the Mac age is going to live there because if I reboot my computer, I don't need to re-register that Mac immediately. It just needs to stay there for a minute. And then when the computer comes back up, the Mac is still on that port. Great. Well, now you're looking at access points where you pull in how many Macs on one port, right? So you start to look at timers on things like that. There's so many ways that we're going to have to start to build those best practices and mitigate around this to make sure that we don't shoot ourselves in the foot.
And you bring up a good point about plugging in, going into an office and plugging in your computer or plugging in something. A lot of the trends we're seeing today is that's not the case anymore. You aren't going in and plugging in your laptop. You don't have that IP desk phone sitting there that you plug in. It's all wireless. Mm-hmm. You go in and there's one AP hanging on the ceiling and that AP is covering 15, 20 cubes and there's not a wire other than power. They'll give you power, but there's not an Ethernet cable, running to each one. And we had a webinar and we were talking with Rona Davis from the cable plant. That's amazing lady, by the way. We were talking to her and she said what they used to recommend 4 drops to every cube. So if you were going to run 1 drop to a cube, you used to run 4. She said now they recommend 2. So if you're going to run 1, go ahead and run the second one, but they've cut that in half because she said everybody's going wireless. She goes, a room that used to have 20 drops now has 1 for an AP and 1 for a display that's up on the wall that they wanted to wire in. She said the rest of it's all gone wireless. And I've seen that and I've heard that from other people. So, this whole mobile society and wireless offices, it's changing all that. So it is. And the question, instead of being a best practice, it's more of a, have that conversation. Because if you're going to wire, then you look at it different. But if you're going to go to a wireless office, where all of a sudden you used to need 200 switch ports and now you need 20. There's a lot that changes, not just from Wi-Fi, but from wired, from the TCAP. I mean, there's all these things that change, but they still have to follow the 802.11 and 802.3 rules. So if you start from a standards-based perspective, you can have that conversation and figure it out. And then from there, then you can start building a best practice for that customer.
Yeah. And that's what it really comes down to, right? Is understanding your customer, their requirements, their needs. Trevor and I talked about this last week. Put your SE hat on, right? Go into a customer site. You're probably going to sit down with a CTO or the director of network ops and things like that. And you're probably going to get a very clear understanding of what their vision is for that network for the next 5 years. Awesome. Where's your engineer? Let me talk to him, because I want to understand what the actual day-to-day needs of this network are. Because when you talk about moving to a more wireless infrastructure, absolutely. Most of what folks are doing now is email driven, SharePoint driven, right? We're pulling documents down. We're sharing documents. The documents are pretty lightweight. We're not talking about gigabytes of data most of the time, unless you have these spreadsheets that make your eyes go crossed. But for me, if I come into, give me the cable, because if I'm moving 2 gigabyte ISOs around and I'm having to push stuff to data stores and VMware and back and forth, if I have a group or a team that's doing things like that, then yeah, I want to throw a cable at their desk. I mean, there's just needs for that sometimes, right? Depending on the amount of data that they're pushing. For typical, probably 90% of what folks are doing, yeah, Wi-Fi is perfect. You don't have to have all that added cost in infrastructure, and the physical aspect of it can be more of a headache and cost prohibitive. But then you look at this and the infrastructure that we can build, that changes everything at that point. And that's really the key, is understand the needs and the requirements of what you're walking into.
Yeah, and we can get into 802.11ax and 8x8 radios that run 9.6 gigabits per second and go, do you really need that 1 gig Ethernet cable? But that's another topic for a different podcast.
Yeah, and look, don't get me wrong. I absolutely understand that side of it. I do.
I'm just relax, Matt. I'm just giving you crap.
No. I know. Coming from an operations background, there was always, the server guys that call you and say, your network's broke. Okay, that's a pretty broad statement. Got 700 other applications that are working fine. Sometimes it's a preference thing. Sometimes it's really, what do you need? I mean, when you talk about AX and 8x8 radios, do you really need a cable? Anymore? Probably not. But it just comes down to it and depends. And one of the main reasons why I have a cable sitting in my laptop right now is because I have it on the same segment as a NAS that I'm pushing data back and forth to all the time. So that's the real reason there. I could do it otherwise. It just removes all the middle stuff. That's the main reason.
As a wireless person, you start to learn that wireless should really be your last resort. And people are really amazed, because I was on a webinar and they were like, man, your stuff sounds so good. You must have great Wi-Fi. And I was like, well, I do have great Wi-Fi, but I'm actually wired in, because I know that my computer doesn't really get up and move a whole lot from my desk. So at least not now. So I ran a cable to it, because I can pick up my laptop and I can roam throughout my house. But if it's going to spend the majority of my time on my desk, I'm going to wire it.
Yeah.
And so people are always really amazed when they find out that my house has great Wi-Fi, but it also has a better wired infrastructure than I have Wi-Fi, because I know when not to use it.
Having everybody's working from home situation, that's probably a really good quality of life decision too, because if it's there and it's wired, you're less prone at 8 o'clock at night to go grab your laptop and start hammering away on something. So it's probably a good thing.
And again, that's a whole other podcast to talk about working from home and Wi-Fi and residential stuff. So we won't go there right now.
Well, you have a standing invite, so we're going to have to cover that one as well. Yeah, and it's funny. I installed a rack at my house, because this is what we do, right? So you're not going to build great networks at work and then make your house look like, it's in shambles. So I put a rack in there and got all my stuff in it, and I took a picture of it and sent it to my sister, and she was like, you're such a nerd. She's like, people don't have that in their house, right? I was like, well, the people I work with do.
So what you're saying is, then this shelf up here above my head that has I think there's 9 or 10 access points up there. That's not normal.
I think you and I might be in a different group. I mean, for us, it's normal, very normal. For everybody else, they're probably like, oh my goodness. Whatever. I mean, it's what we do. And it's your home office now, right? So you also had a blog post about if you have to push different software versions to APs through, single controllers. Talk about that a little bit too, because that's really interesting. I mean, that's some pretty slick stuff you're talking about.
So I discovered this by accident, to be honest with you. And what happened was I came from before I started at CommScope Ruckus, I was a network administrator, architect, engineer, whatever. I was all the hats. And we used somebody else. And so I had this way of thinking, this mindset of, hey, this is how things work. And so, half of my shelf up here of all my APs are a different vendor because that's just what I had. And so I was trying to learn more, and you're always learning. And so I got a Smart Zone 104, the basic Smart Zone. I got shipped one of those for another project. And in playing with it, I realized I was like, wait a second. I have a ZoneFlex 7982, which is an 802.11n. I have an R610, which is an 802.11 AC Wave 2. And I have an R650, R7, and an R750, which is 802.11ax. And I was like, and I want to see how they compare, but that means I have to use different firmware because the 11n won't run on the same as the 11ax. They're just very incompatible. And with other vendors, especially the one that I had experience with, I was like, I would going to have 2 different controllers in order to make this happen. And I was like, that's just nuts and it's too much work. And somebody was like, well, you can do this. And so I kind of started looking at the Smart Zone. I was like, wait a second, I can have multiple versions of code running on the same Smart Zone. And so I was like, I want to see how far I can go with this. And so the blog post that I came up with was a result of that, of going, oh my gosh, I can't believe that I can do this. I was like, this is so amazing, because Wi-Fi engineers always joke about the fact that 802.11n, to your point earlier, was good enough for the majority of the users, and today it still is. Mm-hmm. In fact, 802.11ax is based on the idea that you don't need, and one user doesn't need even 20 megahertz worth of channel at any given time. So we're going to reduce that and make it smaller. Well, 802.11n is still has the same speeds as you can get on a 1RU chunk of spectrum in 802.11x, and so everybody's like, yeah, I can use it, except I can't have it because I can't have one controller platform for every model of AP. And then I went, wait a second, with the Smart Zone, you can. And so I was like, I was just like mind blown, insert the emoji or whatever, just right. I was like, holy crap. I was like, this is a thing. And so I started talking about it with the team. I was like, I can't believe I can do that. And they went, well, yeah, Jim, we've been doing that for years. And I was like, nobody told me. And so then we hired a new SE, or not we, but CommScope hired a new SE, and he's actually a friend of mine, and I didn't even know about it. So I was kind of angry at him for not telling me. And so I started talking to him about it, and he was like, you're effing kidding me. He goes, there's no way we can do that. And I was like, yeah. So I was like, I'll write it up for you. So the blog post that I wrote up was more for my new coworker, a fellow CommScope employee, who was like, I didn't know you could do that. And I was like, yeah, I'll write it up for you and post it. That way you want to go play with it, you know how to do it. And it's amazing, because as I was working on that blog post, I was seeing in the online communities different people going, this makes me mad that I can't do this. And I'm sitting there going, I'm working on this blog post. I know it's coming, where I can go, you know what? There is a better way. There is another option to do this. And I posted it yesterday. And so it's been up for 24 hours. It's had 119 views, and I've had people go, oh yeah, I've known about that. And I've had other people go, I've been running Ruckus for years and I didn't know I could do that. And so, one of the things I learned early on in my blogging career was, if you learn something, type it up and share it. Yeah. And so that's what I did. And people are just like, I've had people, even partners, I had a partner tell me, I didn't know I could do that. And I'm like, yes. So these are things I'm working on, some others, sort of around everything that I've learned about Ruckus and what Ruckus can do, because every time I talk to the people that have been here a long time, they're like, well, yeah, of course you can do that. Why wouldn't you? And I'm like, you don't understand. Coming from the other side of the fence, it really was, it's not a matter of the grass was greener on the other side. It really is dead grass over there.
Yeah.
And we have good grass. So I'm going to talk about the good grass because I didn't really even know that the good grass existed. I thought it all tasted like dirt.
It's amazing what happens when you water it.
I mean, another one that we're sort of playing around with is the site. I mean, the idea of having the standalone code version on an AP, that's not across the board.
Right.
Not every vendor of AP has that.
Yeah.
And it's one of those things where, and we're realizing as newcomers to Ruckus, that, there are things that we didn't know about. We prided ourselves on being, we're both CWNEs, and we're coming to Ruckus and going, wow, we didn't know about this. We are both tech field day delegates. So we pride ourselves on knowing what the industry is doing. And we're like, we didn't know about this. So as part of our effort, we're like, you know what, we're going to start making a little bit of noise, and we're going to start talking about all these cool things that Ruckus, old school Ruckus people just go, well, why would you do it another way? And we're like, because it's the only way we've ever been offered.
Yeah. It's all we know. Right. And
yeah,
that's really interesting. I'm going to put a link to your blog in this too. So just in case somebody's listening to it, how do they find it?
So my blog is Jim's Wireless World at wordpress.com.org. I don't remember.
Self-advertising is definitely a string. No, I'm just kidding. I think it's .com because you sent it to me yesterday. I looked at it. So I'm pretty sure it's wordpress.com, but I don't know.
The easiest way is to find me on Twitter. I'm at Wireless Jim P, and there's a link to my blog in the bio. So,
okay, well, I'm putting all of that in the description because it belongs there. So,
but you can find me on Twitter pretty easy. And in fact, I was having a conversation yesterday on Twitter about the Smart Zone and different code versions. So, come find me there. Probably
one of the few happy, wonderful educational spots on Twitter. I didn't know those existed. So
they don't. You really have to limit who you follow on Twitter to get to those.
You really do. It's terrible.
They're there.
Oh my goodness. Keyboard warriors never go away.
Yep.
Jim, I can't thank you enough for all of the effort and work you're doing. I think that, just in my circle of people I know and how much it was eye-opening to them, I can't imagine how many people this will really help open their eyes to it. So for everything you're doing, thank you. I hope you'll come back here soon because we have a lot more to talk about, obviously, and there's a lot of great things that you're doing. So you always have a standing invite. But I was going to try and get some highlights out of this with the video, but OBS decided to kind of freeze up on me a couple times. I don't know what's going on with that, but hopefully I can still get some of those done and post them as well. But thank you so much. Seriously, I know you're busy. I know you have a lot going on. Taking the time out to do this, it's very much appreciated.
You're welcome, and it's fun to be here.
Yeah, absolutely. All right, well, we'll do this again soon, and everything you need is in the description. Go read the blog. It's worth it. It's really good. So you did an awesome job. So thanks for doing that.
Thank you.
You got it. All right. Thanks. See you, everybody.
Thank you for listening to Ruckcast. If you just found us for the first time, be sure to follow or subscribe on your platform of choice so you can be notified of future episodes. If you have ideas for future episodes or can't find Ruckcast on your favorite platform, contact us at ruckcast@comscope.com. And as always, thanks for listening.